Welcome back. In this video, we will be discussing the scientific method and scientific models. The scientific method is the process of studying natural phenomena. It involves three broad steps: making observations, forming hypotheses, and then performing experiments. Observations may be either qualitative or quantitative. A qualitative observation is subjective and can be made using one of the five senses. How does it smell? How does it taste? What color is it? Does it feel rough or smooth? What type of sound can it make? A quantitative observation, also called a measurement, is objective and involves a number and a unit. The object is 3.12 grams. The liquid has a volume of 5.89 milliliters. After an observation is made, a hypothesis is formulated to explain the observation. A hypothesis is a proposed explanation for a phenomenon that can be tested. Testing of a hypothesis is carried out through experimentation. A testable hypothesis contains one dependent variable and at least one independent variable. An experiment determines the effect on the dependent variable when a change is made to an independent variable. When more than one independent variable exists, only one independent variable is altered per experiment to determine its effect on the dependent variable. The results of experiments always produce new observations, which can be used to modify and improve the hypothesis and lead to further experimentation. Here's an example of a hypothesis and how to test it. Lima bean plants grow at a faster rate with longer durations of light exposure. The two variables stated in the hypothesis are the rate of growth for the plant, that's the dependent variable, and the independent variable is the duration of light exposure. The hypothesis can be tested by using a set of lima bean plants, each exposed to light for a different amount of time. If one plant may not be exposed to any light whatsoever, a second plant may only be exposed to light for 6 hours, a third, fourth, and fifth plant may receive 12, 18, and 24 hours of light, respectively. By altering the independent variable, the effect on the rate of plant growth can be observed. At the end of the experiment, the observations can be used to modify the hypothesis for further experimentation. For example, a modified hypothesis may be lima bean plants grow at a faster rate with longer durations of light exposure to light within a certain set of wavelengths. After repeated testing and modification, A hypothesis or a group of hypotheses can be combined to form a scientific theory. A scientific theory, also called a scientific model, gives an overall explanation of natural phenomenon. In other words, it explains why or how something happens. Once theories are developed, they are not static. Scientists continue to perform experiments in order to refine theories. They do this by making a prediction based on an existing scientific theory and then perform an experiment to determine if the results support or refute the prediction. These new observations are used to improve the existing theory in order to gain a better understanding of the world around us. In science, a theory is supported by all available evidence and considered to be as close to a universal truth as we can find. When the same observations occur repeatedly through an extensive set of experiments, a natural law can be derived to express the observed behavior. In other words, a scientific law is an analytical statement, a mathematical formula that tells us what things will do. It is important to note the difference between a scientific theory and a law. For example, let's discuss gravity. Einstein's theory of general relativity is the currently accepted description of gravitational forces in modern physics. It explains why a gravitational force exists between two objects. Remember, a theory explains why or how something happens. Newton's law of universal gravitation is a mathematical equation that determines the force of gravity between two objects based on the square of the distance between them. We can calculate the force between any two objects as long as we know the mathematical variables. Remember, a scientific law calculates what happens. Throughout our course, many scientific laws, given as formulas, will be used to find the answers to our calculations.